Yeah, see my screen okay?
Yep.
All right, great. Well, thanks everybody for coming to Cloud Native Madison's March 2022 meetup. As I was telling Kurt when I was opening up my slide decks to make a copy and prepare the opening notes today, I was glad I opened up from March last year because it reminded me that this is actually our 3-year anniversary, which is funny because it feels like it's been about 10 years. Not because we haven't had a lot of fun doing this, but because the state of the world has been so crazy since then. But it has indeed been 3 years, and we're really proud of that and very happy that we've had you all continue to tune in every month, and it's made us one of the most active CNCF meetup groups in the world. And so just want to send a heartfelt thank you for continuing to tune in with us every month, and we're looking forward to continue to bring you all a bunch of good content, and hopefully sometime maybe even later this spring or in the early summer being able to get back in person sometime and reintroduce the networking aspect, which I'm sure we're not the only ones who missed that. So real quick, organizers of the meetup are Kurt, who's giving our speech today, myself, Brad and Tim, and Steve Lowry from Integral. So this is the time of year when two big things usually come out from CNCF. One is the annual survey, the developer survey, and the other is kind of their annual report. So I thought real quickly I would walk through some of the highlights from these two artifacts that come out here in the spring. So the first one that came out from the developer survey is just the interesting demographics of people responding to the survey. And particularly of note, it's North America is actually fallen to third in terms of the number of people responding to the survey. So, I mean, that's interesting and fantastic, and kind of shows that this is truly a global and diverse group of people who are working in this space. We've had a lot of uptick in Europe and Asia, and also particularly in Africa. I mean, 11% of respondents coming from Africa. I mean, they're just exploding with a number of technical hotbeds there. So it's really cool to see that. And again, it just makes our software and our communities that are around those software ever more diverse. So I thought that was interesting and wanted to call that out. One of the big themes from the developer survey and the annual report is they're really feeling like Kubernetes has kind of crossed the chasm. And so for those who may not be familiar, this is sort of a common model for how folks have been thinking about sort of software adoption for quite some time now. And the idea here is that innovators and early adopters make up a relatively small amount of the total people out there who might adopt your technology, but they're the ones who are really going to be on that bleeding edge and kind of prove that it's ready for sort of enterprise use, prove that it's ready for those pragmatist conservatives down the line. And as you'll see in some of the upcoming slides here, I think the overall sentiment is that Kubernetes really has kind of crossed that chasm into being, if not the de facto choice, certainly one of the top choices for any sort of way a tech company may want to deploy their technology. So with that, 96% of survey respondents in the survey this year are either using Kubernetes in production or are evaluating using it in production. And what you see here is a breakdown of that by the region that the folks were responding from. So again, you see in Africa, 73% of people who responded in Africa are using Kubernetes in production. I think that's just really, really awesome to see. These other numbers are probably what we would have expected over the years, but this is one of the ways that I think it's really been cool to see the evolution from companies who are kind of using containers but not ready for Kubernetes yet to people who are using Kubernetes in production, and how that continues to grow over time. Another interesting tidbit I got here was 79% of respondents are using what are called a certified Kubernetes distribution. And so that's going to be either a cloud-based Kubernetes offering or sometimes a packaged Kubernetes offering such as Red Hat's OpenShift. And so the interesting thing here for me is, when we started this meetup several years ago, I think a lot of our attention was on Kubernetes itself, right? And how to kind of get yourself onto Kubernetes and start playing within that ecosystem. But I recall at the time, several of our speakers, and I think Kurt and myself as well, in some of our early talks kind of hinted at the fact that we thought that if this community really takes off, then Kubernetes is going to become sort of the boring substrate of all the cool stuff we can do on top of Kubernetes. And so I think what we're seeing now is the industry is kind of showing that that's become the case, that most people are just using a cloud provider or a certified distribution to run Kubernetes so that they can kind of focus on the interesting things that come along with on top of that platform. And on that note, another big thing that the CNCF called out is that organizations are indeed starting to move up the stack. And in this sense, what that means is they're starting to adopt more and more cloud native technologies that get deployed on top of Kubernetes on top of that. And so you'll see on the right here some pretty massive growth in the user adoption of these various projects. I believe all those projects on the right are graduated projects. But so we're kind of entering a new phase now where almost 100% of people who want to play in this space are already using Kubernetes, and now they're starting to adopt more and more of the things that you can build on top of Kubernetes to kind of get closer and closer to that application layer and all the interesting things you can do there. Another interesting call out that was in this survey is that adoption of serverless platforms has remained fairly flat. There's about 39% of respondents last year, as well as this year, who are using serverless platforms in production. A vast majority of those who are using it are using a cloud-hosted serverless platform, which I'm sure doesn't surprise anybody. And what you see is a breakdown here of sort of adoption per region of each one of these serverless platforms. But I think it shows sort of the power and the flexibility and the composability of the Kubernetes-based cloud native stack, as opposed to some of these serverless platforms where it's really easy to get started, but you don't have near the flexibility and options available to you to kind of take your applications and your operations to that next step. So I thought that was interesting and worth calling out there as well. Quickly moving on to the CNCF annual report, the end user community, so this is companies who do not make cloud native software, but use and maybe augment cloud native software, has continued to grow at a good clip, 17% growth year over year. If you're from a company that isn't a member of the CNCF end user group, I highly encourage you to do so. It's really affordable. Kind of the cost scales based on the number of employees you have at your company. And especially once we get back to being able to go to in-person conferences again, it usually comes with a good number of those conference passes. So it really pays for itself if you're planning on sending people to Cloud Native Con / Kubernetes Con that year. Again, we have a lot of project growth this year. So we had 42 new projects accepted into the CNCF in 2021. So that's great to see. And we had a problem loading a slide. Let's see if that'll reload. All right, moving right along. Okay, well, I think what I was showing there was just the projects that had graduated. So I'll just go ahead and skip through that for now. So that was a quick overview. You can find all of that, all those reports in the developer survey results, including if you really wanted to dig into the raw data from the survey results, out on GitHub or on CNCF's website. Our next meetup is going to be April 5th at noon. We are still seeking a speaker. So if you are interested in giving a talk, please reach out to Kurt, Steve, or myself, which you can do through the community site. And again, like I mentioned earlier, we're starting to talk about the possibility of resuming in-person meetups in the late spring. I mean, we definitely don't want to rush into that, but with the way things are trending at the moment, we're thinking in 3-4 months maybe we might be in a position to do that, and just wanted to throw that out there. So hopefully we can get back some in-person networking. And with that, I'll hand it over to Kurt Roekle, who is a solutions architect at Styra, and he's going to be talking about authorizing GraphQL with Open Policy Agent.
Yeah, thanks, Brandon. And just to add to those growing list of projects, I just saw the news yesterday or today that Knative has been accepted in the CNCF now as well. So that's more big news there coming out of the CNCF. So let me try to share my screen. Let's see how this goes. There's a problem sharing your screen. Try using another browser. Well, that's let's.
Where's Steve with his dad jokes?
Yeah, exactly. Oh, well, this is embarrassing because I've done this plenty of times. I am going to try to reload the browser here. I do have an update that needs to be done. So let me update that, reload, and see what happens. So yeah, somebody tell jokes as I'm gone. I'll be right back.
All right, sounds good. I guess I'll mention the slide that I was missing that Google Slides refused to load, was showing that we've had several new projects in the CNCF portfolio graduate up to that incubation level. And there's some really cool stuff in there, including one that we've kind of put out a call for proposals for a couple months ago called Crossplane. Crossplane is basically trying to provide sort of a vendor or cloud agnostic API and control plane resources across any cloud. So just want to plug again that if that's something that you're interested in and you might be interested in building a talk around, please consider reaching out to us. And with that, it looks like we got Kurt back.
Yes, how about that? Just a browser reboot and it worked. So, okay, I assume you can see my screen? Okay, cool. Yeah, so thanks for joining us this week. As I told Brandon as we were coming into this, I haven't really run through this presentation, so I don't think I'm going to go over in time, but we'll see. Hopefully, I'll leave enough time at the end for questions for this. So we are going to be talking about authorizing GraphQL with OPA. The important part there is authorizing the GraphQL. So a little about who I am. As Brendan said, I am a co-organizer here with Cloud Native Madison. 20 years of experience in software engineering. Currently a solution architect at Styra. And I just want to be upfront. I am not the foremost expert on GraphQL or OPA, although I'm pretty good at OPA at this point in time. Of course, as I was thinking about this, I might be, one of the top 10 on the combination of GraphQL and OPA at this point in time. And I did, just win the Event D championship at the Superior 5 and under Bondsfield. So if you know anything about curling, that's not all that impressive, but I put it on there anyways. So what we are going to talk about today is using OPA to authorize the GraphQL request. So we're going to go through a few different things. First and foremost, I'm just going to gain an understanding of GraphQL. I know GraphQL isn't familiar to absolutely everybody, so I want to go through it and just make that make sure that people have an understanding of that. Gonna sort of understand the uniqueness, and as I start explaining it, we'll start to see some of that uniqueness of what comes into play when we're going to be authorizing GraphQL. And we'll go over the way that I chose today to present the authorization, and we're going to see that there's other ways to do that as well. And I'll talk about some of those, but I'll pick one way in particular to authorize them today. Go over some of the other tools involved there, give a nice little diagram, and then we're going to go ahead and, I haven't had any technical difficulty so far today, so I'm sure the live demo will be just fine. So let's talk about GraphQL for a second. So GraphQL, it's a query language, and of course that's what the QL stands for. It's a query language for your APIs. Not only is it the query language itself, but it's also a server-side runtime for the APIs as well, where that we start seeing some of the differences what we expect or we normally see in the REST APIs. There is a schema behind it, and so the schema is what sort of generates everything and gives you that nice query language that you can go off of along with it. The GraphQL document is normally passed in as the body of a post, although there's other ways to pass it in as well, but the normal part of it is the body. And the document itself is not JSON. Now, the body of the post is, but it puts it into a field, in a big string field with the actual document, which is not JSON. So we start seeing some of the interesting things right there, even around how we begin to start to authorize things, because normally we don't get into the body so much as we're doing authorization, but GraphQL, it's all about the body. And if you really think this is really sounding, somewhat like SQL, I like to think of GraphQL as, somewhat of a simplified SQL, for your APIs, but it adds in some polymorphism. So, when we talk about like the schemas and the query language, we do get a very, very similar feel to that SQL. Although, like I said, it's going to be certainly simpler than SQL to understand and all, but it does add in, some of that typing that you're used to in maybe some object-oriented languages. So just looking at some of that schema here quickly, in this, we start to see, some of those complexities there. So, and this is just a small part of the schema. And the schema I'm going off of here, this is a one off the reference application there. And that's, you can go out and search for it. And I have some references here at the end that you can point to. And so with that, so we do have the concept of interfaces and types. And so we start to see some of that polymorphism in play here. So we have an interface called character, but that character is implemented by, in this case, a human type or whatever. If you haven't guessed already, this is, and their examples are off of Star Wars, so it should be familiar to everybody here as well. But so the interface themselves, we have the ID on there, and the exclamation point at the end of it just means that it's a required, part of that. So apparently in the Star Wars world, you are not required to have friends because that is not required at that point in time. And then, of course, the different types can have some additional properties on it as well, as we see, in that human, where they do have, starships and total credits and whatnot as well. So that's, just, and again, I'm not going to go over the real basics. It's just to give you an understanding of, what that schema may look like. And on the flip side of it, the example for a query document, looks somewhat like this. So the query and then the operation name, which is that hero for episode, is, for the case of a query, is a optional thing, although it's suggested to use that. But if you left that part off, it would take it as a query and just execute that query. And as we get into the examples, you'll see that's how I actually did it. But then we see this hero. And that hero, starts to, again, we start to get in some of the differences here. That hero itself is, think of that as, a field or just a field name at that point in time. There's an actual type behind that as well. In this case, it's actually a character, that same character we saw in the schema beforehand. But we don't necessarily know that's a character at this point in time. So as we start authorizing this, it's probably more important to authorize based on those types rather than these names, because these could just be arbitrary names at that point in time, just referenced in the schema as such. There might be times where maybe you want to authorize down, based on that, being hero name, friend's name, something like that. But normally I would think that you'd want to see that as a type. And just, if you remember from the schema itself, friends is also a character type here as well. So let's sort of compare those differences, from what we're used to in RESTful service compared to GraphQL. So normally in a RESTful service, you're going to return all the data properties, from that resource. As you make that call, you're going to get that properties. Now there's some, APIs that are set up to maybe select down or hide some fields that you don't need or add some additional ones. But normally, we get all those fields back. Where GraphQL is sort of the opposite of that. As part of that document, you're telling it what you want to get back from that request at that point in time. So you can be as granular or verbose as you want in terms of the number of fields that we're getting back from that. When you want to join through those things, in the REST world, you're typically making different API calls. Now, of course, if the API is set up with sub-resources and stuff like that, you might get through some of that. But a lot of times you're making multiple API calls to get things off of different RESTful services. Whereas with GraphQL, all that join logic is built into the schema. As you saw that sort of that query, when we went from hero to friends and whatnot, that was actually, doing a join for us. And we didn't have to think about that. That's where I say it's more like a simplified SQL, because in SQL, we'd have to sort of set up that join where being built into the schema like that, we can just keep referencing down through. So a lot in the REST, a lot of that information for that inbound authorization can be found in the headers and URL. So, a lot of times, we're working off that path, the method, whether it's a post or a get, and, using some of the headers as far as, like our JAW tokens or whatnot, to get who it is and everything. So we can get a lot of that, just off of, what can be found in the headers and whatnot. Whereas, as I mentioned, the authorization for the GraphQL, again, you'll have something in the headers. Maybe you'll have that JAW token in there, but that URL means nothing because it's always going to be that same URL. We really have to get into the body to start understanding, what somebody's actually requesting to get into that authorization. And then we need to, in REST, we sort of need to trust the documentation. I know we all really trust documentation, so that's not really an issue most of the time because all documentation is perfect. Even when you're generating that documentation from the APIs directly, there's always still things to fill in or whatnot. So you always have a little nervousness around the documentation. Whereas with GraphQL, it does allow for introspection. So that's going to help aid the understanding in the tooling. We'll actually see that in some of the tooling that I use here in the demo. So it really helps you understand that what's available extremely nicely. So how are we actually going to do this authorization? So there's several techniques to do an authorization. So we're going to use, one of the simpler techniques and one that you're probably a little more familiar with, with your REST services. If you're trying to access something that you're not supposed to access, we're going to give back a 403. So that's what we're going to do here. But there's other forms of doing that authorization in GraphQL, and some of those forms can be, somewhat like you're modifying that document itself. So if you don't have access to a particular field, maybe you just drop that field off of it or return null, or if it's not a nullable field, just go up the chain until you find a nullable field and null it out there. So that's another way of doing authorization with it. Now, the reason, for two reasons I'm not doing that today, one, and probably the primary one, is the way I'm going to set this up right now. I'm going to put I'm not going to tie into the services themselves. I'm going to put a proxy in front of the service. And so this type of authorization could be used absolutely in any device that you can put a proxy in front of it. So if you have a device that's making your GraphQL, or if you're coding your GraphQL in your own service or whatnot, really doesn't matter. You could put this in front of it as long as you get a proxy in front of it. Now, the proxy I'm going to use is Envoy, another graduated CNCF project. But the problem with the Envoy plugin, at least how it sits right now, is when you do external authorization, it's only capturing the inbound side of it, not the outbound side of it. So if we wanted to start nulling out columns and stuff, we'd probably want to do that on the outbound. Or we could, modify that body on the inbound, but the plugin does not allow for us to do that right now as well. I am on the side, working on a different plugin for Envoy that would do both of those things. And then, at that point, but we could use a lot of these same techniques that I'm going to show you today when we do that side of it as well. So ultimately, that's why we're showing just to return a little 403 with that. And I also think it's sort of the simplest for people to understand as you're getting into the authorization. And then we can build into the more complex stuff later on. So the other tools, as I already mentioned here, we're going to use OPA for doing that authorization. It makes sense because I work for the company that created OPA, but it makes sense because, if you're doing microservices and whatnot, you could use the OPA for, authorizing your REST services, your GraphQL services, your gRPC services. You can do it, for your Kubernetes cluster or whatnot. So OPA is, very general purpose, and it makes sense to utilize it. And lets us externalize and decouple that authorization from the actual implementation. So it works nice in our case here. And I am going to show it, through a free product, and I'll have a link for that free product as well. It helps you manage the OPAs themselves in your environment. Envoy, as I already talked about, and right now we're just going to use Envoy itself. But if you have a service mesh, many of the service meshes are based on Envoy. Kuma, Kong, Istio are all based on Envoy. So we could always tie into those Envoy proxies as well that are part of your service mesh for doing the same sort of thing. So there's a couple of other things that we have to do. So I sort of alluded to it already. Or maybe I didn't allude to it, but the document itself, that comes from GraphQL is not a JSON document. It is they have their own proprietary DSL that you use for that. And OPA, in a lot of the other world, works a little better with JSON documents. So that document doesn't, work so good. And so what I've done is I have a service there. Again, part of the reference implementation of GraphQL does give you the ability to translate that GraphQL document into an AST, and that AST, that abstract syntax, that will be a JSON form as well. And so we can utilize that in that. Ultimately, and since I know a couple of people at OPA, and I know there's an open ticket out for it, I think we're going to see some built-ins into OPA at some point in time to sort of do that translation, probably even a little beyond, just that simple translation into the AST. So that service won't be necessary in the future, but for right now, it is going to be necessary for us. So, when that document comes in, we're going to make a call out to, from OPA to that service to translate it so we can get into it in a working form with that. And then once we have it into that AST form, that AST form is not a real fun thing to write rules against. I'll show you a snippet of it, but it gets it gets very complicated. So I have, put out a set of Roekle helper libraries to help people, to get through that AST and to be able to write very simple rules to help authorize things. and we'll show that in action here as well. So how this is all going to look here. So the important thing here is, again, as I mentioned, the example app is, like that Star Wars GraphQL service, so we can all understand, everything that's going into there. And so that service is just a service. I did build an actual service around that. And so, I do have that in a Docker container running here, and I'm going to do this all in Compose on my local machine. As I mentioned, we're going to put an Envoy proxy out in front of it. We're going to tie it into OPA, and then we're going to call out to that AST service. Now, normally I would throw that as a local host call here, but just to simplify things, I do have one of these running out in a cloud run. That we'll just take that container out there to do that translation. So open call out to it. And again, I'll leave that out there if people want to try this at home, and if they want to play around with it right now, I'll show you the link out to the page where you could even try to keep up with me right now and try to do this on your own. And again, as I mentioned, we're going to manage a lot this OPA, really the rules around that through DAS. Just, helps us get the rules out there a little easier for a demonstration at this point in time. And the other thing that's going to come into play is the actual schema. So OPA, is set up obviously to be able to bring in other data sets along with it as it does policy evaluation. And so one of those data sets we have to bring in is going to be the schema because we want to get down to that character or that type information because that's more valuable when we're creating rules into it. So with that, now we are absolutely going to start playing with fire here. We are going to jump over and we're going to start setting this up. So I do have this in here. Let me paste this out if people do want to use this. And I'm sorry, but we're going to you'll get a lot of these screens here, but here we go. If you want to follow along, I pasted that into the chat here for you. So the first thing that we're going to do is we're going to actually, you'll have to create a free system out here. I already have a free system out here, but we're going to create a system in here, and we're going to create an Envoy system for our GraphQL service here. When we do that, it's going to give us a set of install documents here. Now, this install is generally going to go off of, be for a Kubernetes environment. And right now, I'm going to run this in my local, for Docker Compose here. But I do need a couple of things from this. I do need the token. So the token will allow maybe I should copy the C along with it as well. The token is going to, give us the ability to talk back to the system within DAS. So I'm going to take that and I'm going to update my bearer token here. Update it. There's two places in this file here. In these files are all out in that repository that I just posted out for you. So you'll have these configuration files. You'll have the Docker Compose, the README that steps you through it in the AST schema that we'll need here in a little bit as well. The other thing that we have to replace in here, and when you replace things, you'll have to replace the URL in here as well. I explained that in the README doc. But we also need the system ID. So you can find the system ID within DAS. It's this ID here if you didn't give it a description, else you'll find this up under general where you can copy it here, or when you're on the system, you can see it up in the URL. But here we will replace this everywhere. And now we're going to go ahead and save that, and we're going to run our Docker Compose up for that. And if I did everything okay, it'll start up those services there for us. And we do see that the service is up and running, and the OPA is here running for us as well at that point in time. So at this point in time, we have a running service. And just to show that Compose a little, maybe I should show that. So Again, it is that, we're grabbing an Envoy, we're grabbing this Star Wars service, which I do have in a Docker container out publicly available for people if they want to just test with this sort of thing. And then that OPA, and the OPA points back to this configuration that we just updated. Now, the one thing I did mention, and I do want to point out here as well, is within that Envoy configuration, typically when you set up Envoy for external authorization, again, we don't normally get into the body of things. But when we do want to get into the body, we have to additionally configure this external authorization filter with request body here. So this is telling Envoy then, and specifically the plugin within Envoy, to grab that body and to give it along with us with it when it passes that on to the, whatever's doing that external authorization. In this case, OPA, as we see here, the target is going out to OPA at this one time. We can get to the max length. I don't think we're ever going to get up to a couple of meg with a document there, so that should be more than fine. If it does go over that, it would just give that partial document, which would probably break a lot of things, but we'll see. Okay, so we are running out there, so we should be able to hit this service now just fine. And so Insomnia works very nicely with this. So it is running on port 7001. So now if I just do a simple query here, it should work against mine. So in this case, I'm doing a simple little, again, against that schema that's provided there, selecting down to just the episode. And here's the nice thing. Yeah, we can, look at all those, from the schema it'll pull up here because it's done that introspection for us, but it'll give us some code complete here as well. So we can look at these from each of the episodes here. Apparently in the Star Wars world within GraphQL, there's only been 3 Star Wars movies ever made, which I can't really disagree with. So, so we have a running service here, and those are all being authorized by OPA at this point in time. And if we come back into here, if we've given it enough time, we have given it a little time here, that it's actually, we can see these decisions coming back. There'll be more decisions as they get indexed through here. The reason why everything is working right now is because our default rule, says allow, when we set this up. So everything is really cool and working fine, but we want to actually make some actual rules. So we've gotten past these parts here, and I do have a little curl command where you can test that locally as well. But the first thing that we need to do is we need to grab the library. And so I do have a link out to the library here as well, but I'll just copy it over here. So we want to copy this library out from here, and we'll just paste this in here. We don't want the top package, so we'll get rid of that here as well. Again, this library is set up to call out to the another service to do that translation to the AST. And by default, I have that set up to the local host because normally I would, deploy this as a sidecar. But right now, for simplicity, I just have it out on that Cloud Run. And so I do, again, have that example here in that URL that we can just set this up with here to just call out to that at that point in time. So now we brought in that library. Now we need to bring in just some sort of better rules here. So this is our basic allow rule. I'll explain these in a second. We're going to get rid of our other allow from there for now. And then outside of that, we'll bring in some allowed operations. And then I'm going to bring in another helper function here as we start working with groups and whatnot. So what this is doing for us in Roekle language, and Roekle, if you're not familiar with, to me, it's a giant if statement. So we're, dealing with this allow. This is allow condition is what we're calling in initially. We set up OPA to call, or I should say we set up Envoy to call into OPA specifically to look for this type of an allow rule. And then whether it's just returning back a true and false, and by default, it's going to return back false. But this, we can make as many allow conditions we want. In this case, we're going to just show the one. We want to make sure that we're doing an allowed operation, and we're not doing anything with a restricted field or a restricted role. So as long as those conditions are met, this will actually be allowed through it. So our allowed operations, as I copied and pasted them in here already, the first one that we would want to allow is that introspection query. So that does come through, as a query into it and get authorized just like anything else. We want to make sure that gets through okay. And we don't put any other conditions on that typically. That's as long as that's good, we're good. And then we have an allowed operation here, another one, and this is for the query documents. Now, GraphQL does allow for 3 different types of operations. It allows for query, as we're showing here. It allows for mutation, and it allows for subscription. Now, the way I have the library set up here, and we'll talk about some of the important things in the library in a second, but I have the query and the subscription sort of, using the same type of rules, with it. I sort of package those together. Not sure if that is the total appropriate way to do that in the GraphQL world, but that's the way I chose to do it. Then we separate out the mutations because obviously you're going to want to give different rights a lot of times for mutating versus reading. So that's setting up those at this point in time. Now, as we get into the next portion of this, the library also expects a schema to be present. Again, because the library is going to do that translation from what we have in there for references or field names to their actual types. So we need that schema for that. Now, once again, the schema is in that GraphQL sort of form that is a DSL in and of itself, but we can use that same service that we're going to use to translate our queries to AST. We can use that same service to translate a schema into an AST as well. And I've already done that, and I do have a copy, and I have that out in this repo as well. So we're just going to copy this, and we're going to put it into and give OPA access to it. So this is just going to be a regular JSON. We don't want to give it a path in this case, but we do want to give it the name schema because that's what the library is expecting it to be. And then we're going to go ahead and just post that in there, and we're going to publish that out to give OPA access to it right away. So here you can start to see the funness of the AST. It is very, embedded. It goes many layers deep, and it gets a little confusing to work through. We have our operation types in here, and then embedded within that, we have, finally we have what type of operation it is. But then we also have other types. I mean, it's just, as we get into the fields, we get into even more crazier stuff. So it gets very difficult to work with in a normal fashion. And that's where, having libraries like this will really help us out. So with that, we do have now a setup here. So let's go back, and it's going to be a little easier to explain it from here, so that we have multiple types of rules at this point in time. In fact, let me just publish this quick as I talk about these. So this will get published out there. But we have 3 basic types of rules that are provided by the library. There's the query types, and this query types is going to give us the actual class in property within that class that we can use. And this will probably be the one, or we have the equivalent mutation types here as well. And this will be the one we'll probably use most often when we're doing authorization, and we would use it somewhat like this. So we take the rule name, and then we'll give it the actual type name, and then we'll give it the actual name of our property at that point in time. So that's sort of the syntax that's coming through here that we'll utilize for these rules. So the reference, and this is, I should probably rename this to field to stay more consistent with the GraphQL terminology, but this is what I'm calling the fields, which is just by name, which we saw like hero before or whatnot. This is a function for now. I'll switch this over to a rule, because rules are a little easier to work with for a variety of reasons that I don't have time to get into right now, but I'll switch this over to a rule. But for right now, it is a function, so we would call it, and again, we could just pass in that hero, that name of the reference, and then again, the property name there. Ultimately, this should be, whether it's a function or not, this should be an array, because this could be embedded all the way down. Right now, this is just looking for anywhere in the structure. But potentially, if you're using sort of the path to get there, the specific path might be important as you're creating rules. And then the arguments, and this is where, where we're selecting down on something. So if you saw remember in here, our argument here was, episode empire. So in this case, again, I don't know why I didn't code this up to the type right away, but I will change this at some point. Right now it is using that reference. So again, we're giving it that reference here is the first, the actual property that we're checking for, and then whatever value that would be that we want to restrict down. And so to use these, we can use them just like this. So again, as we set up the rules in here, we were making sure that they weren't restricted fields. So if we want a restricted field, and by default that rule returns false, we would want to add rules in here. So think about everything else in here as boilerplate, and the important stuff here is what we're about to paste in. So if we want to restrict the field, in this case, we are restricting the character ID field to just admins, anybody with the role of admin. Now, I'm certainly cheating with this, just again for simplicity as far as reading that. I'm just reading this off of a header field called group. Obviously, normally you'd bring this out of a JWT token or get their identity out of the JWT token and go to another data set to understand the group information for somebody. Right now, I'm just throwing this in the header. But that's what this is telling us to do. So we're going to say if they are not an admin and they're trying to access the character ID, that should fail for them. So now if we publish that rule out, OPA is configured to check occasionally for that, and we see that might have been, the e-tag here being updated. So we do know that the OPA got that newest bundle there. So now if we go back over here and let's look at what our header is. Our header is admin. And let's see, let's make sure we grab the ID field here. We are grabbing the ID field. Now this should work. We expect this to work, and indeed it does. We see the ID of Luke Skywalker here. But if we are not an admin, let's just say we're a manager, we would expect, and we do, we get a 403 back with that. So good, that's doing exactly what we want to do. And we are doing it again off of the type information here. Even though we're referencing hero here, we're actually doing this off the type information. So that's exactly what we're looking for here. So good, that rule works for us. So let's try one of these other rules then. So let's try, even though maybe you use it a little less often, let's try doing it off of the actual name here as well. So in this case here, again, let's paste this in here. And so now in this case, we'll allow both admins and managers to see your friend's name. Okay, so now my manager should be able to see that. But of course, if I still left that ID field in there, that manager would still be unauthorized because of the first rule. And let's make sure we got updated here properly. There we go. There's the update. Okay, so we're going to leave that in there, and we're still manager. So we should still see a forbidden because of the first rule that we have in there, which indeed it is. But now if we take, the ID back out of there, now with this manager, they should be able to see their friend's name, which indeed they can. But now if you weren't an admin or a manager, and of course, we want to test the admin here quickly. Obviously, that should work for us. But now if you're just a normal user, because you're looking at that friend's name, you cannot see that. So you get that 403 back. So another good, successful rule here for us. Good. So now we've been able to authorize based on class. We've been able to authorize, based on these reference names here as well. So what's left is to be able to authorize, based on the actual ID. And the one caveat, again, I have to the library right here. Right now, the library is just set up for equality conditions. Obviously, we'd want to do things more than just simply equality many times, but then many times, again, maybe you do have just restrictions based on specific things. So this will be useful in some cases, but Ultimately, I'll add to the library to make this a little better. But now what we're saying here is, unless you're an admin, you're not able to look at the Return of the Jedi episode at all. I'm not sure why this would be applicable. You should be able to see all the episodes. I mean, come on, really. But for our example, we will do that. Again, we got our update here already. And so where did we leave it, right? So we are looking at Empire, and we are a user, so we should still be able to see, or we couldn't see that because we're looking at friends. Let's change this back to a manager. Now you can see that, and indeed, the manager can see the Empire episode. Oops, I clicked on that, but it is definitely nice having this schema be able to jump up and tell you what these valid values are here. So let's go ahead and change this. And again, it does give us nice code complete with this tooling as well. So we'll do that. And now, again, we get a 403 on that because we now limited this. And again, then we were doing this based off of this reference here. Ultimately, it'd be best if this was based on character there as well. But again, we did say admins could see it, so we can just change our own rights by updating a simple header, and we can see that episode now. So that is all well and cool. So that is the again the simple way of being able to modify this, and we could, obviously we could play around with this as much as we would like in terms of mixing and matching these types of rules, or even having additional types that we would want to get rid of and whatnot. Or I should say, type and property, combinations, that we'd want to restrict down. It all flows very nicely with that. Now, GraphQL can be, even more complicated than the simple documents that we're showing here. And in fact, you can have multiple documents in this as well. And so in those cases, we do have to name our documents here. And let's make sure I'm naming it appropriately. And indeed I am. And so let's go back to one of these that's going to work for us here. So let's go back to the Empire here. Oops. Of course, I didn't use my code complete, and there we go. Okay, so that still works for us as we expected, but now GraphQL allows us for doing multiple. So in this case, we're actually going to get two documents back. In this case, it should work for us, right? Because it's actually the same thing coming back in both. So we're really not seeing anything different in here. But let's see if we go to New Hope here, what's going to happen for us here. Okay, why are we not getting both documents back? I'm not exactly sure it should, unless we had the same hero in both. I think that's the case, actually, how they are set up. To change, we could actually rename these here on the fly here as well. That's another nice thing that it lets us do. And I wonder if we're having a problem with Insomnia not liking these multiple documents. Let's see if this is actually working how I was trying to test here, because now if I actually hit Jedi, this should fail for us, right? Because we're not an admin or a manager. And we do get a failure here. I'm not sure why it wasn't turning those documents back appropriately, but even when we have multiple queries in here, we are still checking all of those queries. So that's one of the things, if you are embedded in a lot of these queries, that's one of the reasons why, maybe returning a 403 maybe isn't the best, because then, you won't get any data back in this case, because, it's going to return those documents back altogether. And so that's an argument for, going to some of those more complex, types of authorizations and just removing. So in that case, we would just want this removed at this point in time. Of course, this is going to work with an admin. Still curious why we're not getting both documents back here. But this is, it's certainly, one of those things that we would want to, not necessarily do it. So, like I said, it's really a restriction in the Envoy proxy right now for us not being able to rewrite this. And like I said, I'm sort of working on the side for a plugin that would help with that. Ultimately, what I'd love to do is just get that, put into the actual official plugin into Envoy. But as I hear, it takes a while to get things into Envoy as far as updates. Now, the same thing can be, as we look at even a more complex example here. Again, I already showed, being able to rename these as they come through. If we look at this one here, let's make sure we look at an admin so we actually see what's happening in this one. In this case, you do see my hero, your hero, coming through for this because we are seeing this is all in one document at this point in time. That's why I knew this one would work here for us. But here we actually show, being able to go a little further. So now we're saying that on a specific type. So if this hero happened to be a droid, we'll want to see their primary function as well, as we could see right here with this as well. So because we're bringing that schema into play and we're actually looking at these fragments as well. Now, this is one thing I didn't test this morning, so it will likely fail because it is a live demo. But if we now made a change, something like this. So now we want to restrict the droids to primary functions. And again, we want that to just be admins. Now I know I'm going to have to change something here as well. Okay. So now we do expect this to work because it was an admin at that point in time. So let's change this back to, we're going to cheat here. So the manager should be able to see this because they would have been restricted by the Jedi one. But let's do this. Now we would expect another forbidden here because we did look at this. And even though, and so that's one of the other, downfalls of this way is that, we're going to do that based on what they're asking for. So they're asking for it in the event that this is a droid that we're going to do it. Because we're just working on the inbound side of it, we don't know for sure yet if this would be a droid when it came back. So ultimately, we'd want to give the 403 back based on the data that we knew about it as it comes back and gets returned from that request. So that's another, feature that we may want to add into this. Again, needing to update that Envoy proxy to do that. But all in all, I hope everybody got a good good overview of, how you can do some of this authorization. And the nice thing about this is, like I mentioned before, you can put this in front of any, whether it's an appliance or a service, of your own. As long as you get a proxy out in front of it, you can do this authorization with it. Like I say, ultimately, and maybe I'll come back in 6 months or so and have another talk as we get into the more advanced authorization, be able to update that proxy to be able to do that at that point in time. But ultimately, being able to decouple that from the actual implementation, getting that off in front, really enables, the world around, what we can do with authorization, and even, decouple it from our life cycle of our code and anything else goes back there, and potentially even giving access to maybe others even to do this. You don't necessarily have to be a developer to be able to code up something like this. You could have other people in your organization do that. So ultimately, that's why we like to decouple our authorization. We also don't have to worry about any libraries or anything else that we need to bring into it, or any limitations if we are using some device for a GraphQL. There's certainly limitations in that that we can generally get around when we use a solution like this. So with that, we still have a few minutes left. If anybody has any questions, feel free to come off of mute and ask.
Yeah, great talk. Yeah, please feel free to come off mute or drop them in chat. I'll keep an eye on there as well. But I definitely have a few questions. Yeah, so really interesting. The more I see OPA, and you touched on this somewhat towards the end there, but the more I wonder, sort of, as you're working with companies who are implementing OPA, sort of, yeah, where the rubber does meet the road in terms of defining these policies, pushing them out, auditing them, and those kind of things. And so I'm curious, like, are you seeing companies use this a lot for these purposes already? And if so, do these rules tend to like live in a project? Do they tend to live over in like a monorepo somewhere, be managed by different teams?
Yeah, great question. And yeah, a lot of times we do see, it's a mix. I mean, I think we still see initially a lot of the development teams themselves, coming up with these rules. They still generally will separate the rules, from their actual application code. Just again, because when you update a rule, you don't want necessarily a build to kick off when you're using those CI/CD pipelines for that. So we do generally see them saved in a different repo, but of course you can save them in the same repo as well. But more and more we are seeing more non-developers do this. And we start getting into some more of the technical, BA type roles, that might be adding to this. But ultimately, especially in like in the Kubernetes side of things, we see actual compliance teams, be able to update these rules and stuff. So being able to decouple that from the code gives us the ability to start simplifying that and letting these other types actually contribute to it, which is a real benefit to decoupling that, from your code.
Yeah, absolutely. And I'm sure developers love that as well, not even having to worry about the authorization flow for those requests coming in. It's handled totally outside of their process, right? Out at that Envoy layer, huh?
Right. Yep.
Okay, cool. Another thing I was curious about there. So, is there, and this is maybe more of a general OPA question, are there tools out there around static analysis or linting or things like that that maybe operations or compliance teams can put in place to like actually set rules on the OPA policies being generated to say like you can never just leave like an unauthenticated user like wide open access to the endpoint or something like that?
Yeah, so there's stuff like that coming. There's not a lot of that right now, in the ecosystem. OPA is still relatively new in the world and whatnot. It's still going through some growth spurts, and that is definitely one of the things that is being looked at right now is to get proper linters in place for that type of thing. Yep.
Cool, cool. We'll look forward to that. Let's see. Not seeing any other questions pop in the chat. So I suppose with that, we'll end right on the dot at 1 o'clock here. So yeah, thank you very much, Kurt, once again for the excellent talk, and thanks for everybody who tuned in today. We look forward to seeing you next month. Cheers.